This video is for Chapter 3, Section 3, Properties of Functions. The main thing we want to go over is the even and odd functions and average rate of change, which you all remember from Algebra 1 mainly as the slope. So you remember on the average rate of change that, by the way, this is called delta y, means change in x, over delta x, which means change in y, is really y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So basically this is what we're doing it, but we're going to do it in the calculus style that you'll need for next year. So first thing we're going to go over is some graphs real quick. These are these are graphs of even functions. This is your absolute value function. An even function is symmetric about the y-axis. So that means I can fold this piece up. If I can fold these up on the y-axis, they touch and it's symmetric. This one, you know, is y equals absolute value of x. So that's an even function. This one is y equals negative x squared. Of course, the x squared one, the parent function, is also even. And this is part of this last one, the third one, is part of our cosine function. We kind of talked about it. I don't think anyone remembers. But anyway, the cosine function is an even function because it's symmetric with the y-axis. Here's some graphs of odd functions. They're symmetric to the origin. And the best way to, this is your cubic function. This is the your reflection cubic function, and this is part of your sine function right here. We knew the sine function was odd. So basically, let's go over just one of these. Basically what you're doing is if I can take this piece and rotate it twice. So basically I'm going to rotate it, reflect it over the x. If I reflect it, let me see if I can draw this. Over the x, it looks like this. Then I'm going to take that same piece and reflect this piece over the y, and it comes back down here. So this piece here now looks like this piece. That means it's an odd function. Same thing here. I can reflect this down once, then I reflect it again, and I get down here. Same thing with this last one, we'll call C. I reflect it down, go reflect it over the x, then I reflect it over the y. So that's a property of an odd function there. And neither is pretty easy. It doesn't have any symmetry at all. This is your square root function. And these are your exponential and your logarithm functions that we'll be going over in Chapter 4. So Chapter 4, we'll talk about those later. All right. The ones that are going to be on your test are the algebraic kind. So I'll do some that's from your textbook. For example, if we have f of x, basically the definition, if a function is even, then f of x, if you plug in a negative here, then it goes back to the regular function. All right? So that's if it's even. If it's odd, then when you take your f of x and negate it, then it's going to go negative f of x, and that would be odd. Now, evens are easy because you know you're going right back to your original. Neither is pretty easy as well, but odd can be confusing. So let's do some of these. Let's do the first one in the book, 33. So we have f of x equals 4x cubed. Okay, so for this to be even, then our answer should be 4x cubed if it's going to be even. If it's going to be odd, it's going to be negative 4x cubed. And if it's neither one of those, then we put neither. So what I'm going to do is I'm going to see what happens when I do f of negative x. In that case, everywhere there's an x, I put negative x. Well, negative x cubed is negative x cubed, so I can pull out the negative, and that gives us, this is like saying 4 times negative x times negative x times negative x. 3 negatives give you a negative, and we have 3 x's, so that's x cubed. So which one does this look like? It looks like our odd function. So this is our odd function. In fact, this is our cube root. If you go back here to odd, there's the graph of the power function or the parent function. And that's an odd function if you graphed it. Alright, so let's look at this one. The next one's 34. We'll look at f of x equals 2x to the 4th minus x squared. Now if it's an even function, it should come out to look the same. F of negative x should equal 2x to the 4th minus x squared. If it's odd, then you negate the whole function and your answer should be negative 2x to the 4th plus x squared. Basically all you're doing is you're negating the function. So I'm taking my original function and negating it. And that gives me this function here. So let's check it out. I have to show my work, so I'm going to, everywhere there's an x, I'm going to put a negative x. So 2 negative x to the 4th minus negative x squared. Okay, when you square, or you have an even power here, that's just going to make this positive. This here positive. Because you have 4 x's, so that's going to be positive. So you get 2x to the 4th minus x squared. So which one does it look like? Which does this look like? It looks like this one. So that means our f of negative x came back right back to our original f of x. So this is an even function. Okay, let's try one more. We need to try, we'll try 2 more. Let's do, I'm going to try to do 36. So let's do 36. We have 3 h of x. This just means we're using a different function, like order of functions, so don't worry about that. H of x equals 3x cubed plus 5. Now, if this is an even function, then h of negative x equals h of x. And if it's an odd function, then h of negative x equals negative h of x. And what I want to do first, because I know what even looks like. If it's even, it's going to come right back to this. However, if it's odd, let me show you it. If it's odd, then we're going to negate this and see what that looks like real quick. If it's odd, it should look like this. Okay, so that's what negative h of x would look like. So let's check it out and see what this looks like when we input negative x. But what happens here is we already know that when you cube a negative, it's going to be negative. So we get negative 3x cubed plus 5. Okay, so does this look like our original? If it does, it's even. Well, it doesn't, so it's not even. Does it look like what our odd should look like? No. So this one would be neither. Okay, let's do one, what's irrational? Let's do one more. Let's do h of x equals x over x squared minus 1. So if this is an even function, then it's going to look the same as this. If it's odd, so what I'm talking about when it's odd, that means h of negative x equals negative h of x. Now I want to know what that looks like. It's going to look like one or two things. Basically what I'm going to do is I'm going to negate my function and see what happens. Now, this is like saying negative 1 over 1, right? This negative here. Okay, so this means it's either going to be negative x over x squared minus 1, or I could change it and make this positive and this negative, because this equals negative 1 as well. Or my odd function would look like x over negative x squared plus 1. So if I get this or this, that means it's odd. There's two different ways it can look. So you need to know what it looks like. Okay, so let's check it out. And everywhere there's an x, we're going to put negative x. We have negative x over negative x squared minus 1. And what we get is negative x over x squared minus 1. Because this squares out. The negative squares out here. Alright, so does it look like our original? No, so it's not even. Does it look like one of these? Does it look like that one or that one? Well, yes, it does. It does look like this one. So that means this is an odd function. We'll do more of these in class. Okay. Now the other thing we're going to do is the average rate of change. Now the average rate of change, the way they do it in the book is they're going to do it in the calculus way. So let's talk about that. The average rate of change, it's just like your slope, but they're going to use C. So they're going to say the change in y over the change in x equals f of x minus f of c over x minus c. And of course, this is where you have to start showing your restrictions. X cannot equal c. If x equaled c, then you'd have 0 in the denominator. That's why they're writing this. They're giving you the restrictions right up front. They have to. Okay, now, I just wanted to show you what this is like. Let's go to, so this doesn't confuse you. Before, when we did this, when you did in Algebra 1, I'm going to just continue here. It would be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, you already know that f of x equals our y, right? You could substitute. This is just function notation for our y. So I'm going to rewrite this as f of x 2 minus f of x 1. It still means our y, but it applies to the y's here, over x sub 2 minus x sub 1. Now, because in calculus this expression is called the difference quotient of f at c, because they're going to look for what happens here. Instead of x sub 1, they're just calling it c. So what I'm going to do is I'm going to erase this and call it c. but you are not doing anything. Don't let the symbols bother you. Alright, we're doing the same thing we did before. So this is just going to be C, and then you don't need the 2 here, because they're calling it this, okay? So it's the exact same thing as the slope, and that's all you're doing. So let's do 2 problems. Let me go back to that. The 2 problems we'll do is, let's just do 1, because we have to do them twice. It's 15 minutes already. All right. So our equation is f of x equals negative 2x squared plus 4. Now, our equation that we have to use is change of y equals f of x minus f of c over x minus c. So basically they want to know the average rate of change from 0 to 2. So what number is this? 53. So basically we're going to let the c be the 2. So this is from x to c. Now, the only problem is they didn't give you the 2 points. They gave you the x. The x's are 0 and 2. So you have your x's is 0 and 2. You don't know what your f of x is. So you don't know your f of x or your f of c. So you're just having to do an extra step to find the f of c. So when x is 0, and I'm going to put this to the side there, when x is 0, so f of 0 equals negative 2 times 0 squared plus 4, which equals 4. And f of 2 equals negative 2 times 2 squared plus 4, which is negative 8 plus 4, which is negative 4. So basically f of 0 equals 4. So this equals 4, and f of 2 equals negative 4. And now you're just using the slope formula. So f of x was 4 minus f of c, which is negative 4, over 0 minus 4. Minus a negative 4, sorry. Minus 2, sorry. Minus 2. So we get 8 over negative 2, which gives you negative 4. Okay? So it's basically you're just using the slope formula, but all you have to do is you have to find your y. And don't let the c bother you. If it bothers you, change this to x2 and x1 if you want. I don't care. Just don't let the c bother you. Let's find the average rate of change from 1 to 3. And we're going to use the same equation. F of x equals negative 2x squared plus 4. So I know my x's are 1 and 3. And so I need to know what is f of 1 and what is f of 3. So f of 1 equals negative 2 times 1 squared plus 4. So that's going to give me 2. I hope I'm just doing this in my head. So f of 1 really equals what? 2. And f of 3 equals negative 2 times 3 squared plus 4. It's 9 times negative 2 is negative 18 plus 4. It's negative 14. And now all I do is use my slope formula. Let me write it again. It's change of y over change of x equals f of x minus f of c over x minus c. So basically, I'm just taking negative, this one first, negative 14 minus 2 over, and I'm going to take this one next, go in order. So I'm taking this one and I'm going that way. 3 minus 1. So we get negative 16 over 2 equals negative 8. Okay? Alright. And that's all.